And welcome back, boys and girls. Sorry about that last video getting cut up. I ran out of time, and I'm only allowed to make 15-minute videos, and I'm trying to keep them to that much anyway, so that I guess that kind of forces me. This one will make real short, though. This one shouldn't take very long at all. Section 2.2, definition of limits. All right, here we go. We're going to try to define limits in a roundabout way here. So we're going to start with, what does this mean? The limit as x approaches 3, little plus sign right up there, of f of x equals 2. All right. And we're also going to look at the limit as x approaches 3, little minus sign of f of x equals 2. And we're also going to talk about f of 3 equals 1. Okay? So what I write this up here, these are some limits. What does this stuff mean? Okay? So what this means is, as I'm looking at a graph of f of x, I'm going to graph f of x. The limit as x approaches 3, little plus sign means it's called a one-sided limit. It means the limit as I approach 3 on the x-axis from the right-hand side. So from numbers that are bigger than 3. So like, I don't know exactly where I'm coming from. I just know that I need to approach 3, and as I approach 3, the fact that the limit is 2, that is telling me that the y value is going to be 2. That I am at 2. So I don't know exactly where I'm approaching from. Maybe, again, this time I approach from the top. Maybe instead I could, another way I could do this, we don't really know. Maybe I approach from the bottom here and I come up like that. Oh, nothing popped up there. I approach from the bottom and it kind of comes up like that. I don't really know where I'm coming from. This just tells me that as I come from the right, I'm going to approach 2 on the y-axis, okay, at x equals 3. Conversely, the bottom one, the limit as x approaches 3, little negative sign of f of x equals 2, is kind of saying the same thing, but now we're coming from the other side. This is a left-handed limit. So x3 with a little plus is a right-handed limit, 3 with a little minus sign is a left-handed limit. So this is just telling me that, hey, as I come from the left now, again, I don't know where I'm coming from. I came from the top last time, maybe I'll come from the top again. It doesn't really matter. I'm just going to come down here. And I could be doing all sorts of stuff, but as I approach 3 on the x-axis, I need to approach 2. I mean, your graph over on this side could look like anything, any type of function, which maybe I don't have there. It's kind of hard to tell. But it could be anything, okay? We just know that as I get close to 3 on the x-axis, I am approaching 2 on the y-axis. That's what that limit is telling me. This is one way we have of computing limits, is graphically and of looking at things. Okay. This last little piece here tells me the exact value of f at 3. If I were to plug 3 into f, or if I were to look at 3 at f, my value is 1. Okay. So the limit and the value of the function don't have to be the same. Okay, they don't have to be equal. In this case, if I go and look at now, so this was a right-handed limit, and this is a left-handed limit. These are one-sided limits. If I look at the limit as x approaches 2 of f of x, okay, that is called a two-sided limit. I now need to approach 2 from both sides. As we're kind of looking at our graph, I'm going to approach from both sides, and I need to approach the same value for that limit to exist. Okay? So in this case, from the left I'm approaching 2, from the right I'm approaching 2. So because I'm approaching that same value, then that two-sided limit as x approaches 3. Got all these 2's and 3's running around. Because I'm approaching 3 from the same amount, though, because I'm approaching that same value, then my limit then is 2, because they both approach 2 on the y-axis from both sides, then that limit exists, and the limit is 2. Okay? So we have, again, just reviewing here real fast, a one-sided limit from the right, a one-sided limit from the left, and then we have our two-sided limit because there is no plus or minus sign, and so I've got to check that both sides go to the same value. This value of the limit does not have to be the same as the value I get when I plug into my function. They can be different. Okay? That's more or less all the stuff. I'm going to do one more quick little example. I'm going to give you a second to try to do this. I'm going to tell you to pause the video in a second. But here's another quick one. The limit as x approaches -1 from the right of g of x is 1. The limit as x approaches -1 from the left of g of x is -2. And then I know that g of -1 is equal to 0. Okay? I want you to go ahead and sketch that picture real fast and tell me what you think it looks like. So I'm going to say, pause your video, take 30 seconds to a minute, sketch this out, and then come back and check your sketch. Okay, welcome back. I'm going to give you my little sketch now. Again, all I know that's going on, I don't know where I'm coming from, but as I come from the right, I know that I should be at -1. I should be approaching +1. So I should approach this point right here. And again, I don't know, your graph can do anything over on that side. But as I approach -1 from the right, I should be approaching a +1. As I approach -1 from the left, I should be approaching +2. So I should be down here. And I could be coming from anywhere. I'm going to go that way now. Okay? And then at -1, I know that it is equal to 0. So you should have a graph that looks kind of like this. Okay? Again, your lines to the sides might be different, but that middle part should look exactly like mine. If we now looked at this two-sided limit, the limit as x approaches -1 of g of x, because these two limits don't agree, from the left I'm at -2, from the right I'm at +1, because they're not at the same level, this limit does not exist. Okay, so this is how we can evaluate a limit graphically, and this is one of our best ways, one of our better ways to evaluate limits. All right. Okay, let me see here. Okay, welcome back. I got a few examples for us here now to kind of go through, a couple of quick ones. So this first one here, I'm going to give us a quick little graph. Oh man, I should have already had it drawn so I wasn't wasting time. 1, open circle, 2. This is just going to go, little sine wave action. Kind of like that. Okay. -1. Alright, so if I ask you to find f of 1, f of 1 is the value of the function at 1. At 1 up here we have a hole. Down here we have a solid dot, so f of 1 is -1. Okay. Now I want to look at the limit as x approaches 1 up f of x. Alright, so this is a two-sided limit, right? No plus or minus sign, so I got to look at 1 from both directions. As I approach 1 from the left, I'm approaching +1. As I'm approaching 1 from the right, I'm approaching +1. Because they're approaching the same number, that is my limit. That is 1. Okay? If I look at f of 0, that is the value of the function at 0. At 0 in this case, there's a filled-in circle up here, right? So f of 0 is 2. It's filled in up there. And then if I look at the limit as x approaches 0 of f of x, again, I'm going to look from, there's a two-sided limit from the left and from the right. So since this case here, they both approach the same amount, they both approach 2, so the limit in this case also happens to be 2. So sometimes those values might be the same, sometimes they might be different. This is going to lead us in our discussion of continuity later on. If they are the same, this is continuous. If they're not the same, you have things like holes and jumps and things like that. But we're going to talk about that a little bit later on. So we should be able to evaluate limits graphically after this little lesson. And then another way we have of doing limits is numerically. Okay, I can plug in numbers. If I say, f of x is x cubed minus 1 over, x minus 1, and I want to try to evaluate the limit as x approaches 1 of f of x. Well, we kind of have some issues here, because if I plug into this, and we're going to talk more about this on the next video, but if I plug in 1, which is our general standard operation with limits, I'm going to get, 0 over 0, which is indeterminate we're going to talk about. All right? So I can't really plug in. We're going to talk about other things we can do, factoring. That's all going to come later on, things you probably talked about in pre-calc. But we're going to do this numerically. So what I'm going to do is I'm going to analyze this two-sided limit from the left and the right, but I'm going to do it numerically. I'm going to go ahead and I'm going to plug in, like if I want to do it at 1, values that are close to 1 might be like 0.9, 0.99, 0.999. See how I'm getting closer and closer to 1 from the left-hand side? And I can go make myself a little table. Eee, why isn't it writing anymore? Okay, we could make this little table here, and I could go find those values. I also can attack this from the other side, from the right-hand side. Ooh, drew all over my face, I think, maybe, possibly. So from the other side, from the right, would be numbers that are bigger than 1. So like 1.1, or 1.01, or 1.001. Okay? And I can go work these out. And what I'm going to want to do is I'm going to want to make sure that they're approaching the same value, the same number. I'm just going to give you the values here. You could use your calculator to do this. By the way, when you're looking in your book, if you see a little blue T next to the problem, that is like this problem has in the book. That signifies that that is a calculator problem. If you don't see that little blue T, then you probably shouldn't be using your calculator. But if I were to plug this stuff into my calculator, the values I'm going to get are 2.71 if I were to plug 0.9 into F, 2.970, 2.997. And then if I approach from the other side, if I plug in 1.1, I get 3.31. I get 3.030. And then I get 3.003. So we can look at this, even though I was not able to do it graphically. Okay, that's a lot tougher to graph. I can evaluate this numerically by plugging in numbers that are very, very close to the number we're trying to find our limit. It looks like in this case, as I get closer to the one from the left, that is approaching 3. As I get closer to one from the right, that is approaching 3. So because those things agree, the limit of this would be 3. Okay? I said it'd be shorter. It was a little bit shorter, but not a ton shorter. This is the video for 2.2. And we got one more for 2.3 for your next assignment. All right, see you later. Have a nice day.